Oui, bonjour tout le monde. Je suis très heureux d'être ici avec vous à Monaco, à cette merveilleuse conférence de la sécurité. Moi, j'habite à Palo Alto, dans le cœur de Silicon Valley, mais je suis canadien. Alors c'est pour ça que je parle français. Je suis né à Montréal, mais j'avais déménagé de Montréal quand j'étais 19 ans. Alors, mon vocabulaire est celui de quelqu'un de 19 ans. Et je vous assurer que quand j'avais 19 ans, j'avais aucune idée de la sujet de la sécurité. Alors, avec votre permission, je vais donner cette présentation en anglais, mais je vais laisser du temps à la fin pour vous demander des questions en anglais ou en français, et je vais essayer à répondre. Alors, à la sujet. La question dans la sécurité aujourd'hui, the question in security today is how do we continue to protect critical applications in data in the face of great change? Change in the kinds of infrastructure we're dealing with, change in the application architectures, change in the threat landscape when the central thing we're protecting, applications and data, are increasingly a threat. Now, some interesting statistics is that the growth in IT spend, looking out over the last 10, 15 years, has actually relatively flattened out in recent years. And that doesn't mean that there has been fewer projects going on in IT. In fact, the diversity of devices has grown dramatically in the last several years. The diversity of application architectures and frameworks has grown in the last several years. Even the infrastructure itself, from private cloud to public cloud to hybrid cloud, enormous amount of change. So the fact that budgets aren't increasing is simply means that we're doing a lot more with less and asked to command significant productivity gains. At the same time, plotted against that same curve, the growth in security spend has been substantial, in the low double digits. It's really becoming an increasingly significant portion of IT spend overall. And we're spending that some $80 billion worldwide on products alone, on an amazing array of products. Now, there is tremendous innovation from large companies and small. And in fact, this investment of $80 billion only represents a small fraction of the overall R&D investment from companies, from venture capitalists, from investment banks. It's really substantial. But perhaps most significant is the number of companies and products that we're collectively dealing with. Like in most areas of IT, we tend to deal with a few vendors. In security, we deal with 30 or 40 vendors. It's quite exceptional and quite complex. Also interesting, if you plot security losses on the exact same timeline, it's interesting to note that the only thing growing faster than security spend is security losses. In the last year or so, it overtook the illegal drug trade in terms of size and scope, which was somewhere on the order of $600 billion worldwide. Now, there's something fundamentally logically wrong when we spend in an industry record amounts, and yet we fail to catch up. In fact, we seem to be falling farther and farther behind. And it's not a question of innovation. There's tremendous innovation on the behalf of the security companies, and practitioners are getting more and more savvy. The challenge I would submit is actually more structural and architectural. And until we can address these structural changes, I don't think we have a very good chance of trying to turn the tide on this. Our view, and then I'll describe perhaps why, is that this model has to change. It's not that security products go away, but one of the first things that has to change is that we need the infrastructure itself to play a more significant role in security. The notion of a secure infrastructure is not simply one that has less vulnerabilities, is more robust itself, but rather an infrastructure that can be used to lock down the applications and data that sit on top of it, and one that can expose those boundaries to security products as the right context to align those controls, right? To be able to create least privilege around users, around devices, around networks, around storage and data, around compute. Secondly, to expose those boundaries, to expose that context to the security controls themselves so that they can actually leverage the infrastructure not simply as another place to run their product, but rather as something that gives them context about the applications they're trying to align to, that they can use the infrastructure as a control point, and that the infrastructure can protect their position as a security product. Lastly, it's about leveraging both of these to elevate cyber hygiene. You know, it's not always sexy, but it may be the most important thing that we do as an industry, is elevate cyber hygiene. That basic elements, the fundamentals. You know, any sports team practices the fundamentals over and over and over again. And look across the vast majority of breaches that have affected us over the last several years. An incredible amount could have been significantly avoided if the level of cyber hygiene were much greater, that we had more consistent patching, that we had more consistent use of encryption, etc. This is a topic that's been top of mind for us, and in fact, recently we spent about a few months developing a paper which I encourage you to download and read. It's available from us. It is not specific to any product. What it really focuses on is, in a world of cloud and mobility, how does cyber hygiene need to evolve? And are there opportunities to simplify the consistent execution of cyber hygiene? And we boiled it down to 5 principles, which can be aligned to NIST and other frameworks. But those principles are least privilege, right? The ability that things should have access to what they need to and nothing more. Microsegmentation, or the notion of compartmentalization. Just because someone breaks into our environment doesn't mean they've broken into our critical assets. Encryption, more consistent use of encryption in flight and at rest. Sort of things are stolen, it's quite likely all they have is a bag of bits. Multi-factor authentication, so that the issues with passwords, it's simply not enough to have a password to be able to get access to things. And much more automated and consistent use of patching, which has really hurt us, I think, as an industry, because clearly many of the events and attacks recently could have been avoided if the right patches were in place. But I want to start at this infrastructure level, because clearly this is an area that I think infrastructure vendors like VMware have an opportunity to change the game. We have been working on a strategy that is basically leveraging the fact that we have a layer of software across the data center, on compute, and now network and storage, but also increasingly across user devices, mobile and traditional user devices, that sits in between the infrastructure and the applications and data that sit on top of it. And that opens up the opportunity to leverage that relatively ubiquitous layer, of an abstraction layer, to create least privilege or lockdown at a user level. For us, that's Workspace ONE, or at a mobile level. For us, that's AirWatch, or at a network level, there's some technology called NSX, or encryption. And more recently, we've launched a product called App Defense, which is really focused. But the idea is, we're not trying to become a security company. What we're trying to do is allow both users and the security ecosystem to leverage the infrastructure to create least privilege environments. And I'd like to explore this concept of least privilege. It is not new. In fact, least privilege was first developed in the early 1970s by Professor Salzer at MIT. It basically is every program or system or privileged user of a system should have access to the resources with the least amount of privilege they need in order to get their job done. It's sort of the equivalent of need to know. And the power of least privilege is unquestionable. You're getting rid of enormous amounts of non-value added risk. The attack surface is much smaller. And what remains is a much brighter signal and better context for whatever can go through that. Now, at the end of the day, a lot of this concept is also about focusing on protecting what matters, which is at the heart of risk management. Protecting what matters. Now, allow me a bit of a metaphor or an analogy, because I was thinking about if there is, perhaps from personal life, an interesting metaphor that might draw some points home. And along this phrase, it's hard not to think about your children and protecting what matters. And it made me think of my first child, my first son. There's an old saying that your first child is made of glass, and your second child is made of wood, and your third child is made of solid concrete. Have you heard that? I don't know if that translates well. Right? Well, I remember my first child, and I remember that overwhelming experience as my wife and I went through the planning phase, development, functional tests, and eventually general availability. But it wasn't until day 2 operations that we were truly overwhelmed. We sat there staring at this fragile thing that it seemed like a gentle breeze would break him, right? And you start to read all these articles about all the possible threats that might become a young child, WebMD, Dr. Spock, newspapers, magazines, and you start getting paranoid, right? You start seeing the symptoms. Maybe my son has Peruvian swine flu, maybe, and you start, calling the doctor. First, it's once a week, and then it's once a day, and then you're on speed dial. And at one point, there's an intervention, and the doctor says, "Oh, wait, no more." Okay? You can't do this. This is insanity. Okay? You can't be chasing every threat. And the doctor gave us 2 pieces of advice that stuck with me that I think are actually very relevant here. The first is, look, 2 things that you could do that make the most significant impact on the security and health of your child. The first is set up a safe environment for your child. And the way to think about it is, what does your child need access to? And nothing more, right? And that's actually easy in the beginning. You have them in a crib, you make sure the mobile is not too close, you make sure things are farther away that they could pull off. It's a little trickier when they start to crawl, and then you have to child-proof the house. But you don't just say, well, the house is their playground and they can go anywhere. It'd be insane. You'd be welcoming a lot of unnecessary risk. Now, we do the same thing in the hospital, right? Where do we put babies? We put them in a nursery. And when we put them in a nursery, things like access control to the babies is a very straightforward and strict process. And think about spotting something that looks weird in a nursery. Actually, that's a very straightforward thing. Imagine by contrast if we simply put babies wherever we had spare room in the hospital. It'd be insane. Distributed babies, figuring out who had access and doesn't have access and who's connected with that child or remove the child, it'd be an impossible task, simply impossible task. The second piece of advice they gave us was know your child. It's not about, for you, chasing threats. It's about you knowing what's normal. And you call me when things change, right? Some kids cry a lot, some kids don't. Some kids eat a lot, some kids don't, right? Some kids sleep a lot, some kids don't. When things change, you call me. And that's actually what they do in the hospital as well, is look for change and then dive in. The doctor is an expert at maladies and remedies. The parent is an expert at their child. And it's the partnership between these 2 groups that really is at the heart of truly effective care for a child. Now, I would submit that your critical applications and your critical data are your babies. But the last time you had your babies in a nursery in your data center was when you had mainframes and monolithic stacks. But that's not what your applications look like today. Your applications are distributed babies. They are web servers talking to app servers, talking to storage servers, database servers. Sometimes in a very open network, sometimes compartmentalized by all our app servers together, all our web servers together, all our database servers, but there are babies in every single one of them. This attack surface is too wide. It's too complex. And as a result, no matter how many innovative security products that we throw at it, we're left with simply a mess. It's too complex to make sense of, and too often our controls are aligned to the wrong thing. And it's just simply not effective. So what happens? At a network level, attackers who find one way in, one web server, are able to move to all the web servers because we've compartmentalized all web servers together. But applications need to talk to each other. A web server has to talk to its app server. And so very quickly it spreads across this whole environment. We have much more of a generic, relatively flat network architecture. Similarly, on the compute stack, we have very powerful, somewhat generic compute engines that can do not just what the application does, but lots of other things. And the attacker takes advantage of that. They introduce new processes. They change processes. They direct traffic to different things. We need to do two things. We need to shrink the attack surface around applications, right? We have to, first I should say, we have to focus on what we're really protecting. And I would submit we're not really protecting networks or servers or endpoints. We're protecting applications and data. So we have to focus on that. Secondly, we have to shrink the attack surface and create least privilege environments around applications. And then secondly, or thirdly perhaps, we need to take our security products and we have to align them to the applications as well. I mean, otherwise, it's like a football team where every player has decided to play the same position. And while they're all trying to get a goal, they're not actually working as a team and they're not necessarily aligned to the right thing. We have to align to the applications. Least privilege and alignment to applications. That will make, at an architectural and structural level, all the difference in the world. Now, what on earth does this have to do with cloud or even mobility? Very fair question. Think of it this way. Well, let me say it first this way. It's very interesting to me that whenever we discuss cloud, for example, and mobility too, we talk about the unique properties of the cloud. And we imagine all the ways that we could leverage it to manage IT differently or build applications differently. Now, the exception is security. In security, the question almost always is, and how do we secure it? Now, that is a very fair question. But an equally compelling, and I think even more interesting question is, hey, is there a way to use those unique properties to change the model in security? And the reason I think that's important is, this is the first time ever we have an abstraction layer sitting in between the infrastructure where all the controls are going and the applications that we're trying to protect on top of it. It's a map between the two, and it has to maintain the relationship with the two in order to work. It allows us to have an application-oriented lens on the infrastructure. And that gives us a whole bunch of interesting properties. So for example, many of you are familiar now with the concept of microsegmentation, leveraging the overlay of virtualization to say, I'm not going to change the network, I'm not going to change the servers, but I'll leverage this layer, this abstraction layer, to carve out the machines that are part of the medical record system. And I'll give them their own address space and a distributed firewall as a door, entry door to it. And you know what? If some other web servers get compromised, they can't move into this application. They're not commingled together like they were before. Not only that, it means I can take controls, whatever my products are, and I can align them to the boundary of that. It means that all my alerts and logs, it's very easy for me to say, all these relate to the medical record system. It changes the model. Now, one of the things that we've been working on as well is, can we create least privilege, not just for the network, but also least privilege for compute? What's running in those machines? And that would be really interesting. I mean, think of the model that would be so different from trying to do antivirus and find malware, but rather start with just locking that down. Instead of it being a general purpose computer, it's a computer designed only to do what that application needs. When you look inside those machines, what you see, of course, is executables, processes, operating systems, right? And as an attacker, I'll manipulate those things. I will rootkit the operating system. I will introduce a new process or manipulate a process so that it communicates to my command and control server or to move laterally, right? Now, all of our investment today is in products, increasingly innovative products, to find threats, to identify threats. But we're in an exercise of chasing bad. And that is a very tricky place to be totally dependent on, because we are always a step behind in trying to catch up as attackers evolve their strategies. A least privilege model would say, you know what? You start with the opposite. You start by ensuring good. And a model that is solely focused on chasing bad will always, always be more expensive and less effective than a model that starts with ensuring good. Now, how do you ensure good? You got to know what good is. You need a way to always check if it's good, and you need to do something about it if it's not. And there are ways we found to leverage the infrastructure to do this in ways that we simply could not do before. And so what we did is, this is actually a technology we launched just last month called App Defense. But the idea is this: you capture the intended state and intended behavior and intended purpose of various machines, and then you monitor against that intended state, and then you use the virtual infrastructure to automate response. And each of these leverage something very unique about the fabric of virtualization. See, from the virtual layer, you're in a unique spot to see both what's running, but also what was provisioned there, what was intended to be there. Anything you provision, we see. So what did we do? We built something that hooks into something called vCenter, which is our system that keeps a full inventory of all the machines. So we can have a full inventory of every machine you have. And we started to look, where is there embedded knowledge from the application team, right? The application team, they don't want to be experts at security, they want to be experts at applications. But they're actually leaving a lot of embedded information about their application. You're just not using it for security. One of those areas is provisioning systems, infrastructure provisioning, like Chef and Puppet and vRealize, right? You correlate that kind of information with machines, and now you say, hey, that's not just a machine. That's part of the database tier of the medical record system. It was supposed to be running Windows 2012. You know, if you go after the application automation frameworks like Ansible and Maven and Jenkins, you see the software packages that they actually deployed there. Now you see, it was supposed to be running these processes. It was supposed to be communicating or interacting with processes on a different machine, right? It gives you very authoritative context. But even without that, by leveraging our position in the hypervisor, we can monitor in real time, either in production or in staging, and see the kinds of software and also the behaviors on that machine. And systematically start to check off, which of those behaviors make sense and should be part of the intended state. You could do that by cross-checking with provisioning, or by looking at databases of processes, process hashes, or by looking across the environment for similar systems, or across the universe, or by standard templates for off-the-shelf software, for various machine learning techniques. There's a whole variety of ways. The end result is a fairly automated process to present you with your infrastructure in terms of applications, within applications, the services, within those services, the machines, and what state and behavior of that. And out of that, we can produce manifests, birth certificates, if you will, for every virtual machine that describes its purpose, its intended state and behavior. And that can be updated as you're patching or updating the system. These manifests become very authoritative contexts And so you're going to want to monitor against it, but you're going to want to make sure you protect it. And that's a big problem in software. When you put software agents in a guest, you're almost always exposed to an attacker. It's one of the nice things of hardware on a wire. Hardware on a wire, just because the guest is compromised doesn't mean the box on the wire is compromised, and that's still a valid control. But very often attackers can manipulate or turn off controls on the endpoint because they're sitting in the same trust domain. But in virtualization, we don't just have the guest, we also have the hypervisor kernel, the host. And so what we did is we leveraged the hypervisor to create a protected zone. And in that protected zone, we can store the manifests for each VM and a process that in real time is constantly monitoring against it. The instant that someone or something changes the operating system, introduces something new, modifies a process so it communicates to something else, we have a signal. And when you have a signal, now you can act. Now, here's a problem for us in the past, which is I have limited places where I have controls and limited things I can do. But guys, you now have fully automatable software-based infrastructures, right? And we took advantage of that. We built a library of incident response routines that use the hypervisor like ESX, NSX, the network virtualization technology, vReal, other pieces of the virtual infrastructure. So you could snapshot, you could suspend, you could block, you could quarantine, you could snapshot memory, insert full packet capture. So now you can simply say, if what's running doesn't match what was intended, this is what I want to have happen. Now, this may not be the perfect solution for user machines, but for a critical application in the data center, where it's supposed to serve a critical purpose and that machine is supposed to do a very specific thing, probably one of the most significant things you can do to reduce that attack surface is make sure all it does is what it's supposed to do. It's a simple but very, very powerful concept, and it's valuable throughout the life cycle because we're starting to connect together what the application teams are encoding and using that to start triggering how we protect it. And that means we can move with greater speed and stay up to date with them. Think of the security review and readiness, right? I recently launched a service and I went through a 2-month security review. Now my service is a SaaS service. I'm releasing product every week. I can't have a 2-month review every week. So 2 things are going to happen. Either I'm going to get a review the first time, and then after that the security team is out of sync, or they're going to slow me down. And neither one is a very good solution. But in my mind, a secure DevOps, agile security approach is one where security can align with application teams and leverage the same sources of truth on an intended state-based model of security. Right? Aligning security to application teams is very different. Security is almost always traditionally aligned to infrastructure teams, but aligning to security application teams is a very powerful concept. At the end of the day, that's what we're protecting, that's what drives the business. And by connecting these 2 teams, what we're doing is connecting a group that understands threats and responses with a group that understands the applications, like the doctor that understands maladies and remedies, and the parent who understands their child. Now, we've started to take this further and further as a concept, not just leveraging systems with embedded application teams' knowledge, but actually we've been building a mobile companion app so that the console for the SOC, if they're running into an attack scenario with an application, can hit a button and the mobile phone of the application owners lights up and gets them involved immediately. We're seeing someone manipulate or running some Python script in this application, or your application. First, is that you? Are you circumventing the process and manipulating it? Secondly, we were planning on doing X or Y. You know the application. I think this is going to be an incredibly powerful new model to help align security teams and application teams to really embed that knowledge in the system, and that can be extraordinarily transformative and ultimately aligning our security to what matters, the applications and the data. These concepts can actually address so many of the fundamentals across these principles of cyber hygiene. Clearly, the notion of microsegmentation is allowing us to sort of compartmentalize the applications at a network level. The notion of app defense, creating least privilege on the compute, right? So we have more least privilege environments. What we can also do is, and you'll start seeing more and more, we've introduced encryption for data in flight, as well as encryption for data at rest, and to be able to easily align that to an application boundary so that we can say, I need this application to be encrypted. And the same principles will apply at the mobile and user level. Now, we don't have virtualization at that level, but what we increasingly have is software platforms. For us, it's things like Workspace ONE and AirWatch, which are really platforms that sit in between users and applications, or the mobile and user devices and the applications. And those two put us in a position to validate and verify. Is this the right user? Is this the right app? Is this the right device? In a consistent basis. It's the basics. It's about locking things down. It's about having a much smaller attack surface so that if things are still compromised, we're not trying to find a needle in a haystack. We're trying to get rid of most of the hay, and now we're trying to find a needle amongst a few pieces of hay. I'm often asked, what does this mean for all the security products? Do they go away? Well, of course not. Actually, this is what will make many of our existing products far more effective. Because what we've been doing is exposing everything I've just described, not just to you, but to the ecosystem of security products. Now, why does that matter? You know, in the past, we talked about built-in versus bolted-on. I think that was the wrong idea. Built-in, by the way, to me means we just make all the functions part of the infrastructure. I don't think that's right. I think it's architected in. Architected in means we share a common organizational principle. And by exposing the boundary of the application and the context of the application, not only can they see things better, but they can insert themselves in the right place. Secondly, they can use automation, because many of these controls would benefit a lot from also being able to leverage quarantine or blocking or snapshotting anywhere they go. And we have the opportunity to isolate controls, to protect controls themselves. So app defense, specifically, I was talking earlier, for endpoint and detection companies and SEM products, and MSSPs, we're giving them access to the manifests. Or customers can give them access to the manifests, to the incident response routines, and we can even watch over their products to see if anyone ever tries to manipulate it. And it's this combination that can fundamentally alter the basic principles of cyber hygiene and the fundamentals of basic control. It's going beyond securing cloud and mobility, which is important. But more profound is the ability to use cloud and mobility to secure. And I think that's a much more powerful opportunity that we must seize on, because I don't see a way for us to break really ahead of where we are today without making a much more substantial architectural and foundational change here. So, with that, I will break. I think we have about 10 minutes for questions. I'm told I have a translating thing here, but that's going to be very difficult for me because I actually understand a fair bit of French, so I'll be hearing the same things in two languages, although I may ask some of my colleagues in the front row if there are a few words that I don't understand. Yes?
Tom, thank you for the very clear presentation, as usual. I have a question. You spoke about where we can make better work security in application teams.
Yeah.
But also you spoke about issues we have with network operation center, team managing mobile devices, other team managing data centers, and all those people have a different objective and are not completely aligned. So in your mind, what is the best organization we could change in order to be adapted to that?
Yeah, so let me make sure I understand your question. Obviously, I spoke about alignment of security with application teams. It sounded like your question is there a way we can better align even just security and infrastructure teams? And that's a fair question. I will say, as we go into really cloud, and I'm not talking just public cloud, even private cloud, moving beyond just virtualizing, it is changing organizational structures. A lot of roles are converging. And so arguably there is a change management process of sorts. I suppose the most encouraging thing I've seen is that increasingly we're using single sources of truth around things. That the infrastructure itself become the boundaries of the application and how and where controls are placed in a topology. In a virtual environment, there really is a single source of truth because we're starting to do it on that layer. I don't know if this makes sense, but security has always been the last of the party. You know, you design an infrastructure and you design it in a way to anticipate any possible application. And then you build an application and then someone says, hey, security, okay, go secure it. It's like, guys, it doesn't work that way. Now you put me in a very awkward position. But now we have a layer that I think provides us with an organizing principle. And I think that organizing principle is helping bridge some of those gaps that the team that is deploying IPSs or firewalls and the team that is setting up the network can bridge that gap because they actually have a single source of truth. But I don't want to minimize the fact that moving to cloud and software-defined data centers comes with organizational change. And as always, I think actually that's the more profound change than the technical one. But I do think there's the promise to align groups much, much easier in that fashion. Yes, sir.
Morning. It works? Yeah, okay. Just a simple question. How do we integrate this security architecture and the existing security solutions in the data center or in the cloud?
Okay, so the question is how do we integrate our existing security products, our existing, both in the software-defined data center and in the cloud, which is a very fair question. So the way it works is that whether it's at the network virtualization layer or the server virtualization layer, there are essentially APIs that are open that I can't say every security company has already integrated in, but a tremendous amount, and they're open for anyone who wants to use them, allows them to get access to the endpoint information, asks them to get access to traffic, so they basically have taps anywhere in the data center, and allows them to be service chained in a particular order. So picture the, more often than not, in this case, would be a firewall team or a segmentation team working with a security architect saying, this is the boundary of an application. Here are all the security products we have registered in our environment. I need one of those on the boundary, followed by one of those on the boundary, and I want the following policy sets for those two products. Those policy sets would be defined in your security products. But what it does is it says, I can align controls and order controls to an application and choose the right policy sets for that application. And that could be really meaningful. You know, I don't know in your environment, but I see so many environments where you put a firewall in front of a bunch of web servers and you end up with 30,000 rules because you have so many different applications represented in that group. And I don't know the last time anyone removed a rule from one of them, because I don't know if there's a game called Jenga in Europe. It's like you pull these things and then the marbles fall. It's sort of what it feels like. Whereas now that the boundary is around an application, it's a much more focused, logical concept of what control and what policy do I want to place on that boundary. But this is widely open. Our goal is not to be a security company. Our goal is to solve architectural issues and to create least privilege, to allow you to lock down your assets, but then open that up so that the security industry that's developed all kinds of interesting analytics and behavioral detection, et cetera, they can have more context. They can be wherever, they can be everywhere if they want. They can use the infrastructure to respond. And you know, a great deal have done that, from Palo Alto to Checkpoint to lots of IPS vendors to most of the anti-malware vendors. So a great deal of them have already, I hope that answers your question. And we're extending this to public cloud as well. So we announced VMware Cloud on AWS, which has our infrastructure in the cloud. And we're also doing something called cross-cloud, which will provide a single management and control plane across Google, Azure, and native Amazon, also which would allow a consistent approach no matter where your application moves. I don't know, do we have time for one more? How are we? Oh yeah, we have 2.5 minutes. See, I was afraid someone was going to ask me a math question, like if a train leaves Paris at 2 a.m., traveling in the other direction.
Yes.
Oh,
I would like.
Yes.
Well, you explained app defense with the 3 layers of
Yes.
detect, isolate, and repair.
Yeah.
Isn't it the beginning of the artificial intelligence in your system?
Yeah, you know, it's very interesting. AI, and specifically machine learning. Well, I read an article just the other day. It was a former engineer at Amazon who was saying that the real key to machine learning is the right application of machine learning, and not just the definition and the algorithms of it. So his point was that Amazon with Alexa has actually, you know, Google and Microsoft may have actually had more advanced sort of technology around AI, but the company that was pulling ahead was actually Amazon, because they found a killer application for it. There's a lot of uses for it, very good uses for it. Our use of it right now, which I think is a very good use of it, is to help build and maintain the intended state, right? The model of least privilege here, what's key is knowing what it's supposed to be in the first place, and that will change as you update. And the ability to use a variety of data sources to contrast what's running, and then to be able to build with a variety of sources, including other similar systems in a single environment, or potentially across a big population of users, can be very powerful, both because there's large sources of information to glean the result, but it also turns the table on the attacker. If they want to fool the system, now they've got to attack many things at the same time and in the same way. Otherwise, the checks and balances don't match. So our focus of machine learning has really been on this deriving and maintaining intended state, the manifests. Look, it's new. I believe we have something that's very, very good, but perhaps on this stage next year, I'll be able to report, you know, how it's been going for the last year. But so far, I think it looks like a very promising application. But it's not machine learning to find threats. We're actually doing the opposite. We catch, in our labs, we caught WannaCry, not because we understood WannaCry, but because WannaCry, by definition, is not doing what the application was doing. We didn't care what it was. We just cared that it wasn't what was supposed to be there. I hope that answers your question. I think I am out of time. I'll probably stay a little bit afterwards, but thank you so much for coming. I hope that was helpful and a different perspective. Enjoy the rest of the conference.